Welcome to my session at DevOps, Dev First, Ops Last. They put me in the big room, it seems. Somebody wants to see me sweat. Thanks everyone for coming. A couple of weeks ago, I had a talk at Global Azure Bootcamp. Another session at the same time was about Lego Mindstorms. And I saw all these people coming into my room, and I thought, wow, my topic is so much better than Lego. And they came in, they grabbed a chair, and they left. So, doors are closed. All right, DevOps, Dev First, Ops Last. What is the current state of DevOps? When I try to understand situations, I always start by looking back. I always try to understand why are we today where we are. And this is what I'm going to do. I try to share some of my experiences with you. So if there is any questions, just go ahead and ask. I think this is much more about you than it is about me. So if there is anything, go ahead. Okay, so a DevOps pipeline today looks pretty much like this from what I have learned. So you have, as a developer, you have your version control, then you have CI, continuous integration, then you have continuous delivery, continuous deployment, and then finally you are in production. All of this can happen within minutes, weeks, months, whatever, but that's usually what we see today as a DevOps pipeline. So as I said, why are we where we are today? One question, do we need version control systems? I think nobody would argue about that. So when I started as a developer about 13 years ago, source control systems were just appearing. So we were using Microsoft Visual Source Safe. Anybody work with that? Oh, cool. So the one thing was when you checked out a file, you had an exclusive lock on that. So nobody was able to even open that file in his development environment while another one had it open. So it was a very, very exclusive thing. Has nothing to do at all with how Git or Mercurial today work, right? So for one, a version control system keeps your source code safe. So I deal a little bit with computer history. I'm particularly interested in old computer games from the late 90s, early 2000s. And as a matter of fact, lots of source code from that era is lost because all the developers were just merging their code on a single developer's workstation. They exchanged code by means of floppy disks. So there are some archives on the internet today that share source code of old games. But very often it says, well, this is probably not the final version of the source code. This is something one of the developers found on his workstation, and it's probably 2 or 3 weeks before the product was finished. So for one, a version control keeps the source code safe. Yeah. By the way, there was that guy yesterday wearing a Commander Keen t-shirt. Is he in the room? Oh, he's in the Lego talk, it seems. All right. Yeah, but that's the era I was talking about. Wing Commander, Commander Keen, that's the games of that era. Version control systems keep your source code organized. So with Git, it's even possible to undo changes without touching your code. So if you have a commit which doesn't depend or which has no dependencies from later commits, you can just undo that single commit somewhere in the middle, which is pretty awesome. And yeah, commit hooks go along with unit tests quite nicely. So you check in your code and your build server, for example, automatically runs the unit tests associated with that check-in. This is really, really nice, and this really helps a lot. So I think, yeah, there's no arguing we need version control systems, definitely. And the best thing would be to combine them with unit tests, commit hooks, things like that. Also, don't pick technologies that do not support version control systems. So one thing we did back then when we were working with Visual Source Safe was we did a lot with stored procedures. And the development environment didn't allow us to commit stored procedures to version control systems. So our application code was in a versioning system, but the stored procedures were not. That was a real pain. I'd like to show you just real quick. Some of you might know that video. So this is how bug fixing looks like without unit test coverage. I hope you can see it. So he keeps trying again and again and again until finally, So I think this is really a good way to visualize why you should really do unit testing. Otherwise, bug fixing will just become like collecting the stuff that's falling on the floor. Besides that, you really should read that book. It's called Growing Object-Oriented Software, Guided by Tests. Some of you might know it already. The core message that really impressed me here was you shouldn't regard software as a building, but much more like a plant you're growing. So you're growing your code base like a plant, and you back it with tests. It has a lot of good information about that. Plus, there is ways today you can visualize your build state. So we use a UFO for that. Our UFO has two different ways, can visualize two different states. So we have one for the trunk pipeline, another one for the latest sprint pipeline. We have these spread across our office. So if you're a developer, you check in your code, you go to the coffee machine, the UFO turns red, you won't get your coffee. You better go back to your desk and check whether it's been your commit that's been breaking. So visualizing the build state creates awareness among your team, and this is what really, that's the first step of having a good quality of your source code, which is really the first step of DevOps, in my opinion. Besides, if you're interested in software archaeology, you should check that guy's website. They have a reference at the end of the slides. He does lots of great things with old game engines. He analyzes source code back from the day, game engine black book. So he really can tell you why, for example, Prince of Persia was written the way it was. So you do not necessarily understand it, but the guy is really good at writing stories. So the next step in the DevOps pipeline is continuous integration. Again, the question, do we need continuous integration? With version control systems, it was very clear that we need it. I think with continuous integration, it's not so much anymore. Anyone here who is not too sure about whether continuous integration makes sense? Anybody here who thinks it's too much of an effort to really get it done right? Oh, great. So, yeah, we need continuous integration because it makes sure your system is tested the way it will work in production. No arguing about that. We've heard yesterday, there was a great talk by Mike about the monorepo. So that's definitely an option, but just because it compiles doesn't mean it actually works. So you need your integration tests anyway. And so continuous integration definitely makes sense. So here is an example for systems being tested from each other independently. I hope you can see it in the back. So it's So to the left is the paper dispenser, and just above the trash bin is the hot air for drying your hands. So you need either this or that, and yeah, integration testing really helps. The next step would be continuous delivery, continuous deployment. Do we need that? So I think we do, because you can deploy a readily tested artifact, because we did that in the previous stages, on a mouse click or even upon check-in. So plus you are able to roll back to previous versions without rebuilding. So you store your build artifacts in a repository with a defined version number, unless you're doing that Google thing. It really helps a lot in deploying and in rolling back and stuff like this. So yes, we absolutely need that. When I started as a developer, what I did when I wanted to deploy my code was, this is my Eclipse environment. It's still in. I made that screenshot earlier today with Eclipse Neon version 1 or 2 or 3, whatever. So I had my code, then I click the file menu here, click File, you click Export, and then you can choose that you want to export your project as a WAR file. This is how I did my production deployments back then. So needless to say, when we identified a bug and we needed to roll back to an earlier version, I needed to check out that earlier version in my development environment. I needed to do that export thing again. Needless to say, that was a pain. Finally, we made it into production. And still here, there is still one step left we can do with regression tests. So maybe there is some other platforms that can do this as well, but I know for a fact that ServiceFabric does it. So ServiceFabric is Microsoft's equivalent to Kubernetes or CloudFoundry, so for PaaS platforms as such. And ServiceFabric can do automated regression testing when you publish your code to production. So back at Build 2016, Microsoft Build 2016, they had that showcase, that space shooter that ran in the browser. So it was a browser game. It was implemented by using WebGL, so it was really a 3D space shooter in the browser. The backend was ServiceFabric. And they deployed a new version of the backend while playing the game in the browser. And what ServiceFabric did was it reconfigured the load balancer, so it took out one node from load balancing, deployed the new version there, and then about 20% of the traffic have been forwarded to that newly deployed node. And they built a bug into the code base. The bug was that new ships that were spawned, new enemies that were spawned, had 0 energy. So they spawned and they immediately exploded, right? And then they added a regression test to the code base, which checked that a ship must not explode without any impact of an enemy or some other entity like a rock or something like that. And then they deployed that version, and then they were playing on that node that got that 20% of the traffic. And again, spaceships were spawned, they exploded, and a minute later, ServiceFabric automatically rolled back to the previous version, which didn't have that problem. So this is a very massive level of automation, I might say. So from a developer's desk to production, we have multiple levels of tests and of tools that automatically do all that testing for us. So on a developer's desktop, we start with Maven, with Gradle, NuGet, whatever all those package managers are. We have build servers for continuous integration and continuous deployment. So Jenkins is probably the most prominent open source tool there. TeamCity has a standout side from JetBrains. There is Bamboo by Atlassian, repositories. You can use repositories for your artifacts. So once the build server is done, it puts it into a repository, and all the testing frameworks can take it from there. Your deployment takes it from there. It's a very sophisticated tool set, let's put it that way. So if anyone is not aware how a build server works or what it does, the guys from JetBrains will be glad to tell you. Next thing, we are in production. I want to talk a little bit about microservices. I know this was meant to be about DevOps, but I think microservices and DevOps really go hand in hand. They really kind of twins separated at birth. Do we need microservices? What do you think? Do we need them? Hands up for yes. All right. Raise your hands for no. Okay. Yeah, I think we actually don't necessarily need microservices. For example, I talked to that guy from Sennheiser, the audio equipment manufacturer, yesterday. He's working with embedded C. He cannot do. Is he in the room, by the way? Oh, also in the Lego talk. All right. He cannot even do microservices, even if he wanted to. I mean, it's embedded C. It's running on an embedded device, you know. but there is very much we can learn from what we have learned from microservices, even for non-microservice-based applications. So when I still was a developer, I usually managed to mess up new code bases within 2 or 3 years, up to the point when you thought, oh man, let's just start over. And the microservice mindset, which came much later, unfortunately, taught me a few things. So microservices, in my opinion, taught us how to build a proper monolith, for example, and of course to leverage on automation much, much more. So how can we build a proper monolith? That's probably a good question. Anyone in here who thinks he built the perfect monolith? Awesome. Sorry? I'm sorry, I cannot hear you. The ventilation is so loud, but okay, it's very loud up here, probably because of me. I cannot tell you now what the proper monolith looks like because, after all, I want to focus on operators and not on developers. Just so much. Bounded context is really the concept you absolutely need to look at. So identify the domains in your code base. I take e-commerce as my favorite example. Let's say you have your online shop. You have the product catalog, which is visualized on the website. You have a billing system. You have some emailing, some messaging components. You need to send confirmation emails to customers. You need to have some persistence in the background. So there are multiple domains inside of your code. And bounded context describes the concept that you should not mix up your objects between these domains. Because what will happen is, if you need to make a change to your objects because you need some streamlining on the product catalog, so you want to remove some code which is not used anymore, or if you need to add a new attribute to your objects for the product catalog, it can easily happen that your billing system breaks because you're using the same product object in the catalog and in your billing system, because it's all a monolith. Nobody keeps you from, using the same object. And for a very, very long time, people thought it would be the eclipse of software development if you managed to work with a single object from the user interface to the database. Today, I know that this is exactly the opposite. You should define your bounded context very well and keep your objects inside these domains. Because for one, this will provide you with a proper monolith. And for another, if you ever need to go down microservice avenue, you can much easier do all the split up that's necessary there. Because the boundaries between these domains are usually the same boundaries you will deploy as separate microservices. There's also a book on that, Domain-Driven Design by Eric Evans. It's actually a rather old book. I think it appeared 2000s, at the beginning of the 2000s. And you really need to be careful. It's very well written. Unfortunately, there's lots of stuff in it that does not work too well. But chapter 14 or 15 finally is about bounded contexts. And Eric Evans himself said, the one thing he really regrets about his book is that people started reading about that domain-driven design thing, and they were so amazed by the idea that they stopped reading after chapter 7 or 8, way before they came to the real important stuff. So I don't know why he never did a second edition, but he always said if he ever did a second edition, that chapter about bounded context would be much more at the beginning of the book. So check the book. It has some good ideas. Take it with a grain of salt. So yeah, you might want to spare some of these things, but it has some great ideas. By the way, there is really an easy way to identify microservice-based apps on the web. So this is Azure Portal, for example. When my session expired after, I don't know, 30 minutes. And I was wondering, what does that want to tell me? It seems I do not have access. I have added the highlighting myself, so that's not how it appeared on Azure Portal. But you can see three spots that tell me you do not have access. Looks kind of redundant. But of course, there is a meaning to that. Each of these components has his own authentication mechanism, or not mechanism, but each of these components is backed by API calls that are authenticated individually. This is why we get the same error message in 3 different spots. Again, read. Of course, S&S Media, who are doing this great DevOps conference today, they have their web presence, so definitely check what they have. Also check the kiosk outside. Plus, if you're the international readership, if you're not German, you should check that Building Microservice book by Sam Newman. It is a very good book. It does not handle the code level, but it's very close to that from a conceptual perspective. It handles things like how to build a user interface for microservice-based environments and stuff like that. Okay, the next thing I want to talk about is platform as a service. So we have had that DevOps pipeline from the desk of the developer to production. Now I talked a little bit about microservices, what it is, what it does, why we need it, what makes sense, what doesn't. And I think part of that game is the topic platform as a service. So Kubernetes, CloudFoundry, or ServiceFabric, the one I mentioned before, containers, all that stuff. Again, do we need platform as a service? And I'm really proud that I came up with that sentence. It takes care of orchestrating the complexity of complex environments. Complexity of complex environments is probably an inherent problem because it's complex. But, well, so who is not familiar with what Kubernetes, CloudFoundry, ServiceFabric do? I can spend a minute or two. I will just talk a little bit less about myself and a little bit more about platform as a service. Okay, it seems I have time for myself. Cool. It really takes out the complexity because it does so much for you. I have described it earlier with the ServiceFabric use case. You as a developer, that does not really mean you as a person, but much more the developer in his role as a developer, can also fulfill the operations role of deploying there. And that helps developers getting their code into production much easier. Plus, if you have that separation between developers and operators, introducing a PaaS platform in your company can help operations to focus on that PaaS platform you're using. Instead of taking care of hundreds of services they didn't create and whatever. So when I was still a developer, we had, we built that WAR file and we sent it to the operations guys and they put it on that Tomcat. And we told them exactly what they needed to do. And then we told them which SQL statements to execute. So we did our schema updates. And it was really a step-by-step guide how to do that. A PaaS platform would have allowed us easily to push the code to production on our own, plus to run the database scripts from the build server or something like that. Plus, a PaaS platform can make you independent from cloud vendors. So in case you're running in the cloud, who's running in the cloud? About 50%. So cloud vendors themselves have their offerings like AWS Elastic Beanstalk or Azure App Services, so you can push your applications to the cloud platform. But Kubernetes, CloudFoundry, ServiceFabric is a PaaS cluster in itself. So you can run ServiceFabric in AWS, for example. You can deploy Kubernetes to your private data center and to the cloud. So you can easily build hybrid environments without the dreaded vendor lock-in. So Maybe you don't need it, but it can definitely help. So we're in production, as I said several times. What's next? The developer's perspective when you are in production is, so the developer's perspective on the piece of code is he was dealing with a single transaction in a specific problem. What he did had no real impact on real users or on business. He was doing it on his work, on his machine. He wasn't breaking anything. It was all good. He was able to concentrate on a single component, and he had time for a whole sprint to get his job done. So he had lots of time, probably, and usually weeks. So that's the developer's perspective on code that has put into production, that has been put into production. The operator's problem now is that, just as I said, the dev has times for days or for weeks, so let's say for sprints, to get that stuff into production. But if there is a problem, the operator has hours or even just minutes to identify the problem. The larger your user base is, the larger your ecosystem is, the more critical is any downtime. So if there has been really a problem in production, you'd better react fast. And this is the operator's dilemma, because he didn't write it, he didn't do the software architecture, maybe he doesn't even know what the problem is or which component is affected, and even if he knows, maybe he doesn't even know who to call. So when you view that from the other side, where the developer had a single transaction at hand, the operator has to deal with hundreds or thousands of them. The more traffic, the more transaction that potentially can identify the problem. The operator usually has no idea what the cause is unless he knows the developer and he knows what he's usually doing wrong. There is really user impact for sure. So if the website isn't available, there is real user impact. There are lots of moving parts, especially in microservice environments. And a deadline is usually not a week, but much more, as I said, hours, maybe just minutes. So the operator faces completely different challenges as compared to a developer. And when it comes to open source, we have some things that might help the operator to overcome those challenges. So we have logging tools like the Elastic Stack, formerly known as Elk Stack. We have things like Splunk. Splunk is not open source, sorry. We have, yeah. I will fix that. We have, so AWS introduced X-Ray. We have Zipkin for call tracing. If you check GitHub, there is a load of call tracing solutions, all of them specific to a certain technology. There is call tracing for Node.js, there is call tracing for .NET, there is call tracing for Java. I could go on and mention every single programming language I know. Monitoring. Monitoring very often is separated into infrastructure monitoring and application monitoring. So you can use Nagios, for example, to monitor your hosts. You can use something like JConsole to just watch your Java garbage collector go up and down. It's all very technology specific. We have charting and dashboarding. We have Grafana. We have Kibana. Who likes Kibana? And who of you who like Kibana know Grafana? No one, I knew it. I'm sure Kibana can be great when you're not me. So I love Grafana. Grafana is awesome. I just don't get Kibana. I just don't. So what's missing from open source? There's a load. There's so much tools on GitHub, on the web for free. But what open source still is not doing is there is no single unified user interface taking care of unifying all that stuff, you know? It is so hard to have it all on one place. If you are setting up a new operator's workstation, you have to, I don't know, add lots of things. Every tool works differently. So the one thing I don't get about Kibana, for example, is you can expand and collapse different sections of the screen, right? But the UI element that allows you to collapse and expand a section is underneath the section and not on top of the section. You know what I mean? I don't think so. Okay, sorry. You have to see it to believe it. Also, so I said call tracing, log analytics, alerting, problem correlation, topology visualization. There are so many tools, but there is not a single open source project that just takes care of taking what's there, providing a single user interface, a single user experience, probably not even working with multiple technologies. So every solution you find is specific to a single technology. I understand the reason for that perfectly, because a programmer sees a problem and he usually starts developing his own solution for it. And they go like 80% and then they don't need it anymore, or they just don't know how to go on. So who of you started building or is still using his own monitoring bits and pieces in addition to whatever? Oh, I'm surprised. That's really not too much. That's just a couple. Okay. I've talked to some people yesterday, and some of them mentioned they have been building their own solutions. So, yeah, the Lego talk must be full of them today. All right. Plus, what about containers, Lambda functions? You know, you build your monitoring solution, you solve your problem, and a couple of months later, someone comes along and says, okay, we need to do containers. We need to do Lambda functions. So it all starts over again. You need to make your solution, your heartbleed solution, work with the new technology. There is no one kind of correlating that. So do we need DevOps at all? Or do we need DevOps? Yes, we do. Of course we do. Because I think DevOps is really very, very much about the collaboration. So this is what I wanted to focus on when I said there is so much different solutions in the open source space, but no one is kind of orchestrating them into a single user experience. So, and DevOps is really about the collaboration. Collaboration requires documentation. And this is then again what DevOps gave us, in my opinion. Automation is implicit documentation. So if you're creating your Maven files, your Gradle files, your NuGet files, you kind of, by automating the processes you automate, you also implicitly document them, because anyone who can read a Maven file knows what you intended to do by creating that Maven file. And very important fact, DevOps also works for legacy systems. So just the open-mindedness, working together, that works great for legacy systems as well. And so the DevOps pipeline, as you should see it, in my opinion, is not from here to there. I think this really needs to be regarded as a circle, especially when we have deployment cycles of just a few minutes or maybe even weeks. It doesn't matter. You shouldn't stop thinking about your tool set when you are in production. Because as an operator, you know, you need to go the way back from production to pre-production again. Can be for troubleshooting, can be for optimizing your code, but still there are reasons why you need to have not just a one-way route from development to production, but also the way back. So do we need DevOps? Definitely we do. But I hope I was able to make it clear here that it's still a long way to go to close that circle. Also, one very important fact for DevOps is to be a team player. You know, you could argue about whether DevOps is about developers being allowed to operate or operators that are really developers building the operations pipeline, or whether it is just about the mindset that dev and ops just work closely together, no matter whether it's persons working together or it's roles working together. So you really need to be a team player. And there is that saying, there is no I in team, right? I think everybody hears about that already. But I can tell you, there is an I in team. I found it. Anyone, any idea where it is? Don't spoil it. It's here. Yeah, it's in the a-hole. So there is an I in team. Everybody loves it, I'm sure. Learn from others' experience. Read, and lots of it. Check the kiosk outside. Visit the website of SNS Media. Share your experiences. People take 80% from failure and only 20% from success. So if you read a story about failure, you learn so much more as if you would have read a story about success. Because I'm not really a fan of, succeed by failing. I think that's the wrong approach. But if you are sharing your experience, share how you failed, because that tells people what they do not need to try necessarily, because someone already did. And of course, don't be the I in your team. Yeah, by the way, my name's Martin. I started with Commodore 8-bit, so VC20, C64. I built null modem connections for playing Doom and Warcraft back in the day between DOS and Windows. Anyone here from that era? Those were the golden times, right? As I said, I did DevOps the way, so what they call DevOps today. I did that mainly for the Java and for the web for about 10 years. You can find me on Twitter. I'm really passionate about life, the technology, and of course the people behind both of them. I'm really much more passionate about the people behind the technology and not so much about the technology itself. So Kubernetes might be a fine thing, ServiceFabric might be great, CloudFoundry might be the next big thing. But in 5 years, there's something else. Nobody cares about the technology anymore, but you will still remember all the people you've been working with. So just let us not forget about it. Let DevOps be a little bit about that. Yeah, I'm with Dynatrace, and I've been quite a bit earlier done than I expected to, but thanks for listening.